All right, so we move on to lesson 4, and in lesson 4 we are going to look at some few review questions. This is Mastermind Scholars Educational Alliance, where we dream, we believe, and we achieve anything we set our minds to. Now let's move on. This is a review sample questions 1 and 2. That's where we are. So let's click that. So question 1. 2 fair dice and 2 fair coins are tossed simultaneously. What is the sample space for the experiment? Now look at that solution. So you toss 2 fair coin and 2 fair die simultaneously. It means that you have 2 dice in your palm and you have 2 coins in your palm as well, and you toss them on the table, and you want to check the sample space that comes out of that. So for the 2 fair die that you rolled, the sample space is going to be 36. And why so? Because the sample space for the first die is 6. That is 1, 2, 3, 4, 5, 6. And the sample space for the second die is 6 as well, which is 1, 2, 3, 4, 5, 6. And if you combine 6 by 6, you are going to get 36. And 36 becomes the answer for rolling 2 fair dice. Now that is the answer. You see, 1, 1, 1, 2, 1, 3. These are the possible outcomes of rolling 2 fair dice. So you can see that they are clearly like that. Now we move on to 2 fair coin tossed. And that will be sample space for 2 fair coin tossed is equal to 4. Why? When you toss a coin 1, you are going to get the head and the tail. And then you combine that with another coin that has also head and a tail, and that will be outcomes like this. Combining head and a tail with another head and tail, and you get these outcomes. And having these outcomes, you can have the sample space for the experiment to become 36. That is for rolling 2 fair dice combined with rolling 2 fair coin to become 144. I want us to look at how perfectly we can list the sample spaces while combining these 2 outcomes of the 2 dice and the 2 coin. How we can combine these 2 so that we can have the outcomes for this particular experiment. Let's check that out. Now these are the explanations. So the sample space for tossing 2 coin is head, 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 tail, tail, head, and then tail, tail. And these are the final outcomes that we are going to get, or the sample spaces you are going to get for tossing 2 coins. Now let's look at for the sample space for rolling 2 die. Now rolling 2 dice looks like this. You have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1. Did you say 1, 7? No, not 1, 7. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, not 2, 7. There is no 7 on the die. That's an impossibility. You get it? I caught you there. Then you move on and on and on and on and on until you have up to 6, 6. So these are the 2 general outcomes for these 2 experiments. So we did the whole thing simultaneously, but I'm talking about for rolling 2 dice, final outcomes, and tossing 2 coin, final outcomes. Now let's combine the 2 of them. We try to draw a table for that, and you can see we have head, 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 tail, tail, head, tail, tail, combined with all of these 1, 1, 1, 2, 1, 3, 1, 4, 1, 5 until we read 6, 6, but we couldn't write all of it here on the screen. So I write goes on and on until 6, 6. Now let's try combining that. When you combine that, you know that this first box, checkbox, is going to get HH11, HH12, HH13, HH14, and it moves on and on and on and on until we fill this whole box. And these are the sample spaces for these outcomes. And so we find out that that is the particular answer we are looking for this particular outcome. So the final outcome now becomes HH11, HH12, HH13, HH14, HH15, HH16. Because we cannot write all of that, we can write about 10 outcomes and put dot 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 to show that it moves on and on and on. And then we write the last outcome. What will be the last outcome? It's going to be TT66. Those are the last outcomes. TT and then 66. And we combine them and we close our K brackets to show that we cannot write all the 144, but we can write at least a few of them, the start, the end, and a little bit there in the middle. All right, let's go to question 2. Now question 2, a card is drawn from a standard deck and a coin is tossed twice. Find the sample space. So a card is drawn, 52 cards that is drawn from a deck, and then we have a coin tossed twice. It's also 2-2, head, and then tail head. And then if you run through this course, you literally will be able to do this. We have 208 possible outcomes, and I know you can pair them. If you know the whole standard cards, you know the individual cards, you pair each individual cards with the head and then the tail and another head and another tail for this particular experiment, and then you can get 208 total outcomes. All right, so that is it. Let's look at our overview of probability. In probability, we have these 4 branches. Either you have an experiment, a random experiment, event, and then outcomes. These are the major things we are dealing with. And then we have experimental probability, where we work out an experiment and then we find out the probability of having a particular event occurring. And we have, for the event, we have complementary events that actually will not happen or will happen. These 2 are complementary events. We spoke about that. And we have equally likely experiment. We are not being biased. We are selecting probabilities of things that are happening the same way. And we have sure and we have impossible event. For outcomes, we have sample point and we have favorable outcomes. And then we have theoretical classic event. All right. So now, final things to remember. Probability is a quantitative measure of likelihood and occurrence of an event. So keep that. This is the notation, probability notation. Never forget how to write the notation. You need it in your solving. Probability always lies between impossibility and certainty. Probability of an event occurring. If the probability of an event occurring is 0, then it's an impossible event. If the probability of an event is 1, then it's a sure event or a certain event. If E is an event, then probability E complement is the complement of the event. Here is supposed to be a P. So a P of E complement should be the complement of the event. There we have probability of something occurring is equal to 1 minus probability of the event occurring, and this is the same as probability occurring and not occurring should be 1, and then probability of an event is never negative.